Hey everyone, welcome back to Code Happy 101. In this video, we're going to go over designing a hotel reservation system. This is a very popular system design problem. Companies like Square will usually ask this question in their system design round. So if you're familiar how to design this, you'll do great. Let's get started. So as always, when you start your system design interview, you want to start with asking qualifying questions. We can start with what features we want to include in this system design. In this case, we just want to be able to search for a hotel, given a location, a check-in date, and a checkout date. And on top of that, we want to be able to reserve a hotel room for that check-in and checkout date. Next, we want to move on to some calculations that will help us design the system. So we start with how many hotels we want to have, let's say about 200,000. And how many rooms should we expect each hotel to have, or room types? Let's say 100 rooms each, roughly 20 different room types. And how many searches are being made by users, let's say about 100 million views per month. And how many reservations are being made, let's say about 10 million per month. So given these constraints, we can move on to figuring out how much data is being stored and how much data is being moved through the system. So we can do some calculations. So given that we have 2 times 10 to the 5 hotels, 2 times 10 room types, 1 times 10 to the 7 reservations being made per month, 365 days per year. We can compute for, let's say, over 2 years, the amount of data that's being stored. Each record is about a kilobyte, is some assumptions that we're going to make. And you can clarify this with your interviewer as you go about doing this. We can calculate about roughly 3 terabytes of data being stored over 2 years. And that's okay. I think 2 years is a fair assumption that we can make for how long we want to store the data. Past data, we can go ahead and archive into more colder storage. So the live data can be stored in one machine, and the read and write QPSs are roughly 33 QPS for reads and 3 QPS for writes. So it's pretty small problem. The load wise, but there's some intricacies with the system that you'll see that are more important to talk about during your interview. So next, we're going to move on to the core entities of the system, and that's the hotels, the rooms, the room types, the hotel amenities, payments, entity, reservations, room inventory. Next, the APIs. We have a search API, which would be a GET endpoint that will take in some query parameters, the city, the check-in date, checkout date, and some arbitrary query. We have the reservation endpoint, which will be a post. So API / hotel / the hotel ID and a reservation. You can also talk about what's going to be in the body, but we'll know more once we start outlining the tables as to what the endpoints body will look like. We'll have a make payments endpoint, will be a post endpoint, and create and update endpoints as well for the hotel. So next, we'll move on to the high-level system design, and we'll start with the hotel admin page, if you will, which will handle the creation, the updates of the hotel. And usually the hotel administrator will be using this. We'll have a client, we'll have some API gateway, which will be our load balancer, which will terminate SSL, which will gate and route all the requests to a hotel service. And that will route the request to a hotel DB. We can get fancier later on when we do a deep dive as to, we can have a cache if we want to for faster reads and writes, things for faster reads. But for writes at this moment in the high-level system design, we just go straight to the database. And the tables that we care about are the hotel table, which will have a hotel ID, the name, a description, the address, the check-in and check-out dates, or sorry, times, a star rating, and a status. We'll have a room types table, which will have a room type ID, a hotel ID that it maps to, a name, a description, a default rate, that cost per night, and a status. We'll also have a room rate table. We can get more complicated and add more, for example, let's say if your interviewer asks, how would you design if you want to do promotional pricing? So we can have a room rates table that can handle this, which will map to the room type, the hotel, the date, and then the special rate that you can have for that room. And then very important, which is the room inventory table, which will have the room type ID, the hotel ID, the date, the total quantity for that hotel for this specific room type, and the total reserved for that date. So as you recall, we're going to store the data for the next 2 years. That means each day will have a record for this room inventory table for all hotels and for all the room types. Cool. So that's the hotel admin sort of flow, creation and updates. Next, we're going to move on to the search flow. It's pretty straightforward. Any updates that are made to the hotel database, we can have a change data capture workflow that can publish events that will go to a queue that can update, let's say Elasticsearch cache that updates the database if you want to, or we just go straight to the cache itself from our search service. So similarly, we have a client that goes whose routes go through an API gateway. They'll hit the search service. Over here, I drew a database and a cache over here that gets updated. But we can also have it to where the search goes straight to the cache as well. I didn't draw that arrow, but you can assume that that can also happen. For a large system, we can use Elastic Cache. If it's a small system, we can actually have those queries go straight to the database, this hotel DB, and then we can have common queries go to be cached, whose results are cached, and those requests can go over there. So it's pretty straightforward, not too complicated. Then comes the reservation flow. This gets a little more complicated. So the client straight goes through the API gateway. We'll go to our reservation service. We'll create a hotel reservation record in our hotel reservation table, which has a reservation ID, which has a hotel ID, the room type that was reserved, the guest information, ID, email, name, the check-in date, the checkout date, the status, the payment ID, and the total price of the room. So we'll create that record. And if you recall, we have this room inventory table. This table also needs to get updated when a reservation is created. We need to increase the, first we need to check to see if we don't have all of the rooms reserved. So we do a check. And then if it's not, we create the hotel reservation record. So this means that this update and this create record has to be done in a transaction. This means that these tables have to be in the same database. And just to make it simple, we're going to go ahead and make note of that these two tables will be in the same database so that we can check to see if we have enough inventory before creating a record. And then similarly, if a hotel reservation is canceled, we have to go ahead and update this as well. And the reason we want to do it in a transaction is because if one update fails, both updates need to fail. So for the data to remain consistent. So that's a very important note that you have to make with your interviewer. Cool. And so when the reservation is being made, we'll hit an external payment service to generate the payment, and that payment service will could respond asynchronously back with a confirm or deny if the payment was completed successfully or not. And so as a result, we have this the status here. And so if the reservation was, let's say the payment failed, we update the status, and then we also decrement the reserved for the room inventory. So we do reserved first, and we create the reservation record with the status, let's say, created, and then we make the payment service call that will return with the successful payment and a payment ID. We go ahead and update the record, or failure, and then we update both those records. And yeah, that's pretty it there. And some notes that we can kind of highlight here. If as the system grows, we want to go ahead and partition by the hotel ID. That way, the data is partitioned well. And because we're only storing 2 years of data on live database, we're going to archive older data. That should be okay. We can also talk about optimistic locking on the room inventory table on the total reserved. We can talk about a cron that will run periodically and ensure if the reservation status is set, and to cancel the ones that roll back the inventory as well. So the cron is in case, let's say the client creates the reservation, but let's say doesn't submit a payment. They just stop their reservation flow. They don't make a payment. They forget to hit the payment reserve button. So we'll have a cron that runs every 15 minutes, and then checks to see the time that this was created and rolls back the reservation, as well as it decrements the total reserved in the inventory table. So that's what this cron is. So we want to be able to talk about this, how we can account for user behaviors, some edge cases. So the reservation status, like I mentioned, we can have created, pending payment, paid, refunded, canceled, rejected, completed. We can use Elasticsearch to power the search, or use Postgres indexes and vector full text search. If we separate out the reservation DB from the inventory table, then we'd have to use a consistency mechanism to keep it consistent. An option is a two-phase commit using Zookeeper or another technology, which increases complexity. And if you're familiar with this, how two-phase commit works, you can dive deep into that design during the interview. But yeah, that's pretty much it for the hotel reservation system design. I hope you guys learned a lot. If you liked what you have just listened to and watched, please give a like, a thumbs up, subscribe if you haven't yet, and if you like more videos, comment, and if you have any suggestions on different system designs that you want me to do. And if you have any questions, don't hesitate to ask. I'm happy to help out. Yeah, cool. Thank you for watching. See you next time.